Kia ora everybody, it's Jack O'Brien here, and in this tutorial we're going to be looking at over multi-signature scripts, what they are and what we can do with them. There's a document in the description containing all the information relevant to what it is we're doing for this video. There's an ASCII doc file, so if you have the ASCII doc extension in VS Code, you can use Live Preview, or you could just as simply open it up in the Git repository that I have all set up, as well as check out the Live Preview and just have it open on the side in your web browser. I'll be doing this on Windows, but there are also documents for OS X as well as Linux-based systems, so you can use that depending on what distribution or OS you're using. It's important to also check out the previous tutorials, as I'll be, this is a continuation of that. So if you're not familiar with anything or what's going on, I suggest you go check that out, as I'm just going to be going over the basics and the bare runs of setting everything up, but really jumping into everything. So if you're interested, you can check those out in the description below. So before we get started, I want to go have a little bit of an overview over what multi-signature scripts are and what the kind of a process is required to basically execute smart contracts. This is going to give us a little bit of context when we go to actually implement a multi-sig signature script on the Cardano network, but we'll be doing that on the test network, by the way, not the mainnet, but the process is practically identical. You just have to switch a few things. Now, if you're basically not familiar with any of that, or what a command line interface is, or how to set all this stuff up, I suggest you go watch the previous tutorial series I did, which was minting native assets on Cardano, so NFTs. So you can basically check that out in the description below, familiarize yourself with the UTXO model, and come back and we can move on to multi-signature scripts. Or you can just not listen to me and just rip straight into it. Totally up to you. It's your choice. So, native scripts and multi-signature scripts. What are they? Well, native scripts execute in the Cardano settlement layer. So when all transactions come together to be settled and verified and put onto the blockchain, that's kind of where it gets executed. And it lets you specify a policy to spend a transaction output or mint or burn tokens, give or take whatever it is you're doing. And a multi-signature script defines a policy for using multiple keys. So it defines what keys are used to sign a transaction, to make these transactions valid, depending on whatever it is you're doing. Again, context matters. So the simplest policy requires only just one key, and that's it. It's as simple as it can be, just one key. So there are different types of addresses. There's the public key address, which is a hash of your private key and your public key to create an address to which we can send ADA to. There's also a native script address, which is what we'll be focusing on in this tutorial about different multi-signature scripts. And there's also the Plutus script verifier address, which is the smart contract aspect of Cardano, which is Plutus being the domain-specific language that is basically upcoming in the Alonzo hard fork. So witnessing. What is witnessing? Witnessing. So for a transaction to validate, we always need to attach the signature using a private key or keys to the transaction. Witnessing is the act of creating and attaching a signature of the raw transaction using a private key. So if you have your private key and your public key and you're basically about to submit a transaction, it's probably best that you have your private key and your public key in order to witness it, to sign it, to make it valid, to say that it came from you, so that then you can basically push the transaction up. So all transactions have to be witnessed by at least one person, one key. You can't do it without one, otherwise it'd just be spat out, rejected, and thrown on the street, left to die. So actions include spending an output, minting tokens, or burning tokens. Again, depends on what you're doing, give or take what context it is or situation you're trying to do. So let's take a little bit of a nitpick or look inside multi-signature scripts. So a very simple language for witnessing requirements. It's not elaborate, it's not complicated, nor is it complex. It's pretty straightforward. It's just a simple JSON encoded text file. That's all it is. And the keys are identified in the script by the hashing of the public keys. So all the public keys depending if it's Alice, Bob, or Carol, or whatever, and they have all their 3 keys. They hash their public keys, and they paste them into this JSON text file, and this defines the policy of what the multi-signature script is about. So it's the rules for combining different keys. And that's kind of what it allows us to do, to basically allow people from all around the world or within a small little group to define the spending or the holding of certain transactions. So we can add optional things such as time locking restrictions, specify a time range between certain slots that occur. So say you want your script to be valid between the range of 1 and 10, then between 1 and 10, that script is only valid before it basically dies. Scripts and keys. Well, this is kind of what your script looks like. It's nothing too complicated, like I said before, nor is it complex. It's very straightforward. It's just a simple JSON text file of our public key hash and the type signature. And normally you just copy that object and just have multiple different keys. And, that's the term multi-signature script. And then basically have all these different people come together and sign a transaction to when it gets assembled and then submitted. So for a multi-signature support, we're going to need more than one key, obviously, than just this one here. So let's go ahead and spin up Daedalus, our VS Code, and just rip straight into it. Okay, I'm all ready to go. I've got a VS Code session up and running, empty directory. You can really be working anywhere you want with this fresh terminal up and going. I've also got my documentation, which is right over here, over and opened up in my GitHub repository. And the link, again, is in the description. It goes into a little bit more detail about setting this stuff up. In this particular tutorial, it's just a basic overview of setting things up. So the first thing I kind of want to be doing is setting up an alias for Daedalus. And you have to make sure that you have Daedalus open up, because if you don't, then this isn't going to work. Now, I've already gone ahead and run this command, pipe. I've already piped this socket path in here. I kind of have to do that every time I open a new shell, which is a little bit annoying. I haven't quite figured it out, but this is Windows after all. And I've already gone ahead and basically I've already pre-configured my magic ID, which is the network magic necessary to hook in for the testnet specifically, which is this one here. I've already got it up. And there's also the alias. But again, all this is in the documentation in the description below. So be sure to check that out in the GitHub, depending on what operating system you're using, and just follow along in the beginning, as I'll just go over setting everything up. Okay, came in for the part we wanted, which is for generating our script keys. But before I do that, I'm going to go create a new item, because I want to be able to store things in my in a note kind of file kind of thing, to store variables and stuff like that, instead of having to cross over my different monitors and stuff like that. So just a little bit more convenient for me, and maybe for you, to basically have that. So I'm going to make one called note.adoc, type, and then file. And then, lo and behold, a file appears. You don't have to do it through the command line. You can also click this little tab up here and then type in the name of your file and just have it up like that. It's really that simple. This is VS Code after all. So yeah, I've got this. I'm just gonna call it notes. Easy. Sweet. Give me a sec here. I'm just gonna go source, PowerShell. And 1, 2, 3, 4. 1, 2, 3, 4. Cool. Now that I have all that set up, I can pass parameters in here and basically just copy and paste as usual and just manipulate them on the fly using this. And I'm going to save that. My bad. I put a little A in there. Silly me. Okay, now let's get into generating these keys. Now, the first thing we need to do is obviously generating the key. That's simple. Under the section generating keys, we just copy this command here, commandos CLI address keygen, and press enter. And you should have a signing key and a verification key. Those are very important because we're going to need those in the future, to hash them to create, to be able to put them into our script address. And go ahead and do that two more, so that we have 3 pairs of keys. If you check on my side panel, I now have payment 1, 2, 3, verification, and signing keys. Okay, now it's time to go and building the script. Again, you can do it through the CLI or do it through the interface on VS Code. I'll do it through VS Code, and I'm going to call this multisig.json. And just like that, we have a JSON file. I'm going to go ahead and copy this boilerplate that I have in the documentation. Make sure you copy everything as if you miss spaces, and be sure to get rid of these annotations. It's just a little bit annoying that ASCII doc does that. I haven't actually exactly figured out the copy clipboard.js with ASCII doctor, but nonetheless, make sure you copy everything, including these little brackets down here. You don't want to miss those, as when you go to actually submit or build the transactions, it's going to barf at you. And I made the mistake of having spaces in here and basically missing this little curly bracket out there. So make sure you got that in. And we're going to be doing a basic script type, which is all, meaning that all key hashes have to be witnessing to a particular transaction, have to witness a transaction from the script in order for it to be valid. Now, there are 3 different types of transactions, right? So there's the all one, which is what we'll be using today, that indicates all keys must be used to witness a transaction. There's the any type, which is any key listed in the corresponding script can be used to witness a transaction. So it can be any key listed. And there's also an at least. So there has to be at least a minimum number of keys in order to witness a transaction. So you just type in required up here, or something required, and then you just put like 2 or something like that. And then you can basically go on and do your thing, right? So, okay, that's pretty straightforward. But for today, we're just going to be doing the type, all multi-signature type script. So now that we have this going, I think it's time that we go ahead and hash our payment key. So I'm just going to go ahead and run this command here and just repeat, rinse and repeat. So generate the hash for the payment key, and this is, I'm going to paste payment 1 here and save. And repeat that for your other 2 key pairs. And I'm just going to speed this part up and see you in the next one. Okay, now that we've basically pasted in our hashed keys, we can go ahead and basically take all of this multi-sig JSON and generate an address from that. So we can send something to it so that we can have control over the spending of what's in that script. So it's just this little command here, Cardano CLI address build script, and that takes a script file, takes all of that, hashes it, and spits out a multi-sig address. If you can see, we get ourselves a little multi-sig address, and that's our address here. And I'm going to copy that. I'm going to open up dateless, send it, paste it in here, and I'm going to type in 10 ADA, 10 Lovelace, 10 million Lovelace or something. Anyway, I'm going to paste that in, and I'm going to send some ADA over to it. Cool. And just like that, I've sent some ADA, address sent, awesome. And just to test that transaction went through, I'm going to query the UTXO on that just to see the inputs that we have. Oh boy, what did I do wrong? My bad, put in the wrong command. There we go. And we can see we got a transaction hash with our input ID, our TX index, and the amount in there. And that's pretty much all we need to know, because now we can go ahead and start building the transaction and, executing this multi-signature script. So we kind of have to build a couple of environment variables, nothing too strenuous. I've got it all laid out here, so I'm just going to copy everything and then open up my notes and paste it all in there. I'm also going to actually get a slot num, but I don't want to put that in there just yet. I actually might skip that part out, so I'm not actually going to go ahead and actually cut myself for time by stressing to get a transaction out, because I don't really want to do that. So we'll make this a little bit more straightforward. So just go ahead and replace these variables here. And I'm just going to knock off the first 3. I'm going to take the transaction hash, paste it into my TXIN ID, and make sure that the transaction index matches that. And so you just need to match the index here with 0 and 0. If it's 1, then you obviously replace it with 1. And the amount of Lovelace we have, oh boy, my fingers are slipping. Sweet, we've got 10 million Lovelace, we've got a fee of 0, pretty much everything straightforward. I'm going to get rid of that. And in essence, just replace the address with any one of these hashed addresses that you have in daylist so that we can send it back, just to demonstrate this kind of stuff. And I'm going to go ahead and start inputting them into the terminal. So I'll see you when I have done that. Cool. Now that we have our environment variables all set up, we can go ahead and export the network parameters, because we need that to verify a calculate a fee, because we can't not make a transaction and not pay a fee. So we need these protocol parameters to be exported in order for our transactions to basically move on to the next step, basically. So I'm going to run this little command here, and it's going to spit out a protocol JSON job file. So now we can go ahead and start putting transactions. It's just a little minor inconvenience that we have, but it's best that we do that anyway and get it out of the way so that we have it all in there. I'm going to go copy this boilerplate and paste this in here. Now I'm going to get rid of the annotation stuff. I'm also going to get this TTL, which is time to live, which corresponds to the optional time to kill, or the range from which a transaction is valid. In this case, the transaction we're about to build. But everything else is pretty much straightforward. It's really just getting rid of that, copying this in here. And if you've copied the same variables that I have from the file that I'm looking at now, it's just a piece of cake. It's just copying and pasting. That's kind of all it is. And just like that, it didn't bar for me. Thank God. So now it's a matter of, calculating the fee. And this is where the parameters start coming in handy. And if you're doing this with multiple inputs and outputs, you obviously need to change the TX in out and the TX ins relative to the amount of inputs and outputs you've created. If you haven't watched the UTXO video already, just watch it. You'll have more clarity and become more enlightened because of it. And also we're going to be matching the witness counts. And if I assume correctly, we had 3. So you kind of have to match that based on how many keys you're using in the address, or the policy script, so to speak, as it kind of makes a lot of sense, and that we can, calculate the fee from that. So make sure that you match your values correctly with what it is you're doing. And it's going to spit out a number, which is 184,025. Cool. Awesome. And the best way, easiest way to rebuild a fee is just go $ capital fee, paste number, boom. And so if I go fee, / there we go. Whichever number our calculate fee that comes out. Just going to clear my terminal. Awesome. Cool. Once you've done that, it's just a matter of rebuilding fee. So you can press up on your arrow keys to move past your history, so to speak, so you don't have to bother typing everything out. So now we can rebuild the transaction with the calculated fee, with the necessary inputs and outputs, and the necessary witnessing files. And this is the part where we actually start signing the transaction, when we start building everything and assembling the transaction we have. It's not normal, nor is it good practice to have all the keys here. In a sense, it's kind of a little bit too stupid and a sort of a security flaw to have that. But this being just a tutorial, I think it's totally okay. Just don't follow my example. So first step is basically getting our multi-sig JSON to witness the file. Boom, just like that. And now it's just a matter of getting the different keys to witness the transaction. And if you can see the signing keys, key 1 is signing this. And if you're like a guy in, I don't know, Czechoslovakia, Greenland, Antarctica, you basically be given the raw file, which is the raw address of what we have. And then you basically be signing this key with this transaction signing this transaction with the key, depending on what key holder you are, so to speak. It's not really best demonstrated here as it's kind of all in one, but if you kind of follow where I'm coming from, it makes a little bit more sense, so to speak. So go ahead and run the next few key files, which is key 2, and key 3, which is our payment key 3. Awesome. And we can come to the part where we assemble everything, which is Cardano transaction assemble. My phone is going off, sorry guys. And paste that in, transaction assemble. Boom, we got our signed file, and we've generated all these witnesses, and now our transaction is all ready to go. And with any further, hopefully, fingers crossed, it actually goes through. It did. Now it spit out a little message saying transaction successfully submitted, which is awesome, which means we didn't screw up. And we can paste in to make sure that our transaction actually went through, and lo and behold, it did. So if we check our date list, you can see that if it comes back at us, hopefully, it might take a little bit of time before it starts receiving it, I'm afraid, but it went through. Actually, I think now that I think of it, I actually sent it to the wrong address. It actually wasn't one of these, I don't think. I sent it to I think I sent it to another friend of mine, and I was using that as a form of sending a. So don't do that. Don't be implicit like me and just think everything is okay, because even I made the tiniest of mistakes. I didn't actually do this. I didn't actually go receive, copy to address, boom, boom. I didn't actually do that. So I'm an idiot, but nonetheless, the transaction successfully submitted, and it all worked. So now you can basically complete the transaction, go back, try the different types. You can try out maybe utilizing the knowledge. Feel free to just fall back on this documentation or look at the ones on IOHK, which I'll also post up in there in my description below. For any, can try the any one where any key could be used. Try it with your peers, or, get them working with it. Your mom, your dad, your brother, your sister's boyfriend, at least try the different corresponding hashes, give it a go, give it a twirl, totally up to you. So don't forget to, do that, and that's it. That's the tutorial. Thanks. Don't forget to subscribe, check out the description to find out the necessary resources you need, and see ya. Bye.